Number of variables. Some students have questions about how many variables to use in word problems. To some extent, this is not really a mathematical issue, but more a matter of preference. In other words, sometimes students get caught up on, well, is the right way to do it with just one variable or assigning two variables? And it turns out there is no absolute right way. You can do it both ways many times. It's really a matter of discerning what works best for you. So I'm going to show both methods, and it's very important that you in your own practice both ways. If you solve a word problem with two variables, go back and solve the same problem again. Try it with only one variable. See what works best for you. And as you develop a sense of your own preferences, you'll be more comfortable with word problems. So here's a practice video. I'm going to say pause the video and solve this, and then we'll talk about this. Okay. This is a very simple word problem. Frank has $13 more than Glenda does, and together they have 81. How much does Frank have? So first of all, we're going to start approaching this just with two variables. The obvious choices are F and G for Frank's money and Glenda's money. Frank has, so F equals 13 more than Glenda. F equals G plus 13. And then, of course, their sum is 81. Those are our two equations. Well, the equation on the left is solved for F right now. Technically, we want to solve for G because we want to eliminate G so that our final equation has F, because F is our target value here. So I solve for G, I substitute that in, now I have a single equation with F, my target value. Simplify, divide by 2, and we get F equals 47. That's how much Frank has. So that's one way to solve the problem. Let's think about this again using only one variable. Well, for the one variable, the smart variable would be our target value. Our target value is Frank. So we're going to use F. That's going to be our only variable. Frank has 13 more than Glenda. And so it means that Glenda has 13 less than Frank. So Glenda equals F minus 13. And so I'm going to use F minus 13 for Glenda. And then the sum of those two, Frank plus Glenda, F plus F minus 13, that equals 81. Well, this should look familiar. This is the same equation as we had before, so I'm not going to solve it again. It has the same answer. But this shows you whether you start with one variable or two variables, you really wind up in the same place. You may get there slightly faster if you use one variable instead of two variables, but then again, it can be hard sometimes to see how to set up everything in terms of one variable. So that's the trade-off. If you see that you can introduce just one variable and express everything easily in terms of that, then that might save you a couple steps and a little bit of time. Practice with this and experiment. If you find that when you pick only one variable you get confused or have trouble expressing the other quantities in terms of that one variable, then it might just work better for you always to start with two variables. So again, get out of the mindset that one way is right and one way is wrong. This is about finding your own preference, finding what works best for you. And if you find that one choice is more comfortable for you, is easier for you, then by all means go with that. What if there are more than two variables? Well, keep in mind that if we have n variables, we also need n equations to solve for those variables. We did have a lesson on solving 3 equations with 3 unknowns, so that's particularly tricky math, and that's typically more advanced than anything you'd need to do on a word problem. And forget about it for 4 equations or 5 equations. You just don't see that on the test. If a word problem talks about 3 or 4 items, chances are very good that we can relate everything to a single item, which will allow us to create a single equation. So here's a relatively simple word problem. So this is a little more simple than you'd see on the test typically. Pause the video and then we'll talk about this problem. Okay. Mark is 8 years older than Lisa, and Peter's age is 3 years less than 3 times Lisa's age. If the sum of their ages is 80, what is Peter's age? So Mark equals 8 years older than Lisa, L plus 8. That's one equation. The other one a little trickier. Peter is, P equals 3 years less, so we're subtracting 3 times Lisa's age. So 3L minus 3. That's Peter's age. So notice we're expressing both of these in terms of L. Then the sum of the ages is 80. So if we plug in those two top equations, we can just write one equation in terms of L. And so that's often what happens here. Even though we have 3 different quantities originally, we want to get it down very quickly to one equation with one variable. Now this one we just do a little cleaning up and simplifying. We get 5L plus 5 equals 80. 5L equals 75. So L equals 15. Now, very good that we use sensible letters here. L equals 15. That's Lisa's age. That's not the answer to the question. We need Peter's age. So Peter's age, we have to take that, multiply by 3, and then subtract 3. Well, that would be 42. And that's the answer to the question. Now, here's a word problem that is actually worthy of something you might see on the test. Pause the video and then we'll talk about this. Okay, Wendy left the house with D dollars in cash. She made the following purchases: gas for $3 less than 1/3 of D, a book for 1/6 of D, stationery for $6 more than 1/6 of D, groceries for 1/4 of D. After these 4 purchases, she had $4 left. What is the value of D? Well, very fortunately, they give us a variable, so we'll just stick with that variable, and everything is expressed in terms of that variable. So we can say D minus 3, that's the gas, plus 1/6 D, that's the book, plus 1/6 D plus 6, that's the stationery, plus 1/4 D, that's the groceries, plus the $4 left, all that together add up to D. So I'll do a little simplifying. 1/6 plus 1/6 is 1/3. And also neaten up the numbers. They just reduce to plus 7. Now I'm going to find a common denominator. Add all those fractions. I get 11/12 D plus 7 equals D. Subtract 11/12 D from both sides. I get 7 equals 1/12 D. Multiply by 12. D equals 7 times 12, or 84. And that's the answer. In summary, if there are 2 quantities in a word problem, it may save you time to use only one variable. And again, remember, this is very much a matter of personal choice. You need to experiment for yourself. Try it with 2 variables, try it with 1 variable, do that on several word problems, find out what works best for you, and then go with that. If there are 3 or more quantities in a word problem, you'll always want to relate all of them to a single variable and construct a single equation.